Alrighty, here we are ready to start another week, and we will be finishing up Chapter 7 this week. We've got Lesson 7.4 is the last lesson. We're going to break it up into Lesson 7.4a and then 7.4b, and that'll wrap up the whole chapter on systems. So we've done systems of equations, solving with substitution, elimination, graphing, matrices, and we are going to apply that now to systems of inequalities, which is largely based on graphing, but graphing that has to do with being shaded. All right, so let's jump in and let's take a look at how this is done. So we start with what's called a constraint. A constraint is something that restricts you to a certain section of the graph. And when we are constrained to x greater than 0 and y greater than 0, that means we are constrained into the first quadrant. So our solution here is going to live within the first quadrant. So I'm just going to shade that as a reminder that that's what that constraint means. Pretty much all of our questions are going to be constrained within the first quadrant. The second constraint is a line, a piece of a line, and let's take a look at that equation. Now, normally we graph lines in y equals mx plus b form, but I want to show you a different way that you could think about a quick kind of shortcut way. I think is faster to graphing lines when we're dealing with inequalities. What I want you to think about is what would the result be if there was no 2y in this equation. All right, well, let's suppose there was only x's. So if there was only x's, we'd have 4x and 10, and so we divide both sides by 4, and x turns out to have a value of 10 divided by 4, which is 2.5. Let's do the same thing for the y value. So let's suppose the x value wasn't there. And so I'll cross that out. All right, no x value, which means we have 2y and 10. We'll divide both sides by 2, and so y turns out to be 5. Okay, this is the method of graphing a line using what's called the intercept method. 2.5 and 5 are what are called the intercepts along the graph. So let's go to our quadrant here. We know that along the x quadrant, we are now at 2.5. So 1, 2, 3, 2.5 is about right here. And 5, 1, 2, 3, 4, 5 is the y-intercept. And so the quickest way to graph that is to just connect the x-intercept and the y-intercept. So we've got 2.5 connected to 5. Now let's shade that section. Looking at this inequality, because that inequality is less, we need to shade below the line, not above the line, but we still have to stay in the first quadrant. So let's, I'm going to take off some of this other shading. We're not going to keep it. And let's see. Okay. And so my resulting area is this a little triangle. All right, there we go. So we are in quadrant 1, but we are below the line that connects 5 and 2.5 on the x and y axis. And so our solution is a triangle. So your solutions are going to be shapes that are shaded in. Now, it's going to be important for you to recognize what the corner points are. So this triangle has 3 corners. And so you would list the corner points like this. You would say 0, 0 is a corner point. You would say 2.5, comma 0, which is the corner point that lives at the x on the x-axis. And then you would also say 0, comma 5, which is the value of the corner point that lives on the y-axis. So you're going to list your solutions as ordered pairs, and you would have 3 solutions because the graph itself is a triangular section. All right, that's example 1. Okay, now let's move on to a system that's got more sides, so a different shape. Notice that the constraint again is x is greater than 0, y is greater than 0, so that means we'll be living in first quadrant again. I'm not going to shade that in right now, but just keep that in mind. Okay, let's graph the next equation, which is a line again. So I want to look at, we'll do the same method. If y didn't exist, then x would be 10. Excuse me, x would be 5. And if x didn't exist, then y would be 10. And so that line would have the intercepts of 5 and 10. So on my graph here, I'll go to 5, 3, 4, I can try that a little bit better. 1, 2, 3, 4, 5 on the x-axis, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 on my y-axis, and I'll connect those two. That's good. A little better. And looking at the inequality, we will be shading below. Right, so I'm going to end up with a triangular region again. I'll shade that one in purple. Okay, so now a second equation, a second line. So let's check that out. And let's use our same method we were doing before. So let's see, let's do red for that. If there was no y, then x would be 7. And if there was no x, then we divide both sides by 3, and y is 14/3, right, which is 4 and 2/3. So this graph connects 7 on the x-axis, which is over here, and 4 and 2/3. So I'll do my best to draw that about right there, okay? 4 and 2/3. And I'll connect those two. Now the shading needs to be, if we look at our inequality, below that as well. That is also a less than inequality. And so I need to be shading the parts that are less than the red line. So I have to be less than the purple line and less than the red line, but still stay in the first quadrant. So I'm going to get rid of all of the shading here. And so I end up with an overall section that is not a triangle. It's more of a quadrilateral, okay, a four-sided figure. It's not a rectangle, it's not a square, it's not a triangle, it is a quadrilateral, all right? And so my region, and I'll overlap it in yellow here, this is the solution region for this, this graph. Okay, now the corner points. Of course, we have 0, 0 as one of our corner points. Okay. We also have 5, 0 on the x-axis. We have 0, 4 and 2/3 on the y-axis. And then we have this fourth corner point where the two intersect each other. So here's where our techniques that we learned before, how can we find that intersection spot? All right, well, we're going to come look at these equations, and we're just going to use our old methods of solving. Probably linear combination is the best way to solve where they intersect each other. So I'm going to take 2x plus y, and I'll just switch it to equals now, because I'm looking for equals 10, and so an intersection, and intersections are equal. I'm going to multiply the bottom equation by negative 1, and then I'll combine them. So the x's cancel out. I'm left with negative 2y, and then I get negative 4, so y is 2. And then I plug that back into one of the equations. So let's take 2x, the top equation, 2x plus 2 equals 10. Subtract 2 from both sides. 2x equals 8, so x is 4. And so this intersection point here must be 4 for the x value and 2 for the y value. Let's just double check that makes sense. Okay, and it does. My graph is pretty close to lining up to 4 here, and it's not so bad to line up with 2 right there. You should never just trust your graph perfectly, because you could have done your scale wrong or be off by a little bit, so you should always do the math using elimination method to find the intersection point. So my last corner point is the corner point 4 and 2. Now some of you might be thinking, well, what happened to the corner point number 7 and the corner point number 10? Well, they are not in the shaded region, and so we don't have to include them as part of our solution set. Our solution set is only the region formed by the four corners of 0, 0, 5, 0, 0, 4 and 2/3 and 4, 2, and the area that's in between all of those, the shaded region. Okay, all right, now we're really going to look at something new. Look at, we've got 3 different line equations going on here. All right, our constraints are still x equals 0 and y equals 0, and so we're still looking at the first quadrant. And let's get some graphs going. So we're going to use the intercept technique that we were just doing. So we'll look at this equation here, x plus y. Well, it's easy to tell. If there are no y's, then x must be 90. And if there are no x's, then y must be 90. So we are looking at the intercept method, telling us to connect x is 90 and y is 90. All right, so let's connect those two. I'm going to count by tens here. So 10, 20, 30, 40, 50, 60, 70, 80. I'll put 90 right there. And 10, 20, 30, 40, 50, 60, 70, 80, 90. And I will connect those two. Alright, so now I'm going to take a look at the shading on that. Greater than. Okay, see how that is? So that means I'll be shading above this line, below. So I'm not looking at a triangular section anymore. I am looking at the section above this line. So that's different. We haven't seen that before. So it's not below. It's not going to be a triangle. It's going to be, but still in the first quadrant. Okay, so above that line, but in the first quadrant. All right, let's take a look at the intercept method for the next equation. So we'll zoom in on that. For x plus y is less than 180. I think I'm going to have to maybe, I should have planned better ahead. Now I'm going to need 180, so I'm going to need to count my equations differently. All right, so I'm going to back up here a minute. Sorry, so do a quick rewind. All right, here we go. Let's not count by 10. We better count by 20s. So, it's not going to work out good. Yep. Okay, so I'll go 20, 20, 40, 60, 80, 100, and then 20, 40, 60, 180. All right, that's going to be better for my overall graph. So sorry about that. You can, if you're working on Notability, this is easy to fix. All right, so 20, 40, 60, 80, 100, 20, 40, 60, 80, 200 up there. All right, so if I'm going to connect 90 to 90, then 90 would be here, and 90 would be here. All right, this is going to be a better overall graph, and then we'll be shading above that. So this is what happens when you record on live, and I'm not going to go back and re-record what I did. All right, we're staying in first quadrant. There we go, that's a lot better. Okay, the second equation. Okay, if we pretend like there are no y's, and so 4x equals 180, and we divide by 4, divide by 4, okay, then we're going to get x equals 180 divided by 4. All right, so 45. And if we do the reverse for the y's, and we say, okay, there are no x's, then I just have y, and I have y equals 180. All right, so now I'm connecting 45 to 180. I'm going to do that in a different color. I'm going to connect 45 on the x-axis, so I better label that as 45. probably label this one as 90. And then I'm connecting that to 180, which is way up here. And those two things intersect. And I look at the region of the inequality for that one. And this one is a less than. So it has to be less than the blue line, but greater than the purple line. So that significantly changes my shading. So I gotta get rid of all this, because to be less than the blue line means none of this shading can exist anymore, because it's all greater than the blue line. So I gotta get rid of all of that. And again, when you have Notability, it's really easy for you to do and get rid of. Alright, I've got all that erased, and now we're going to look at our last equation. And get rid of the 5s, divide both sides by 10. So x is 80. And then doing the same thing for the y's, we'll find the y-intercept, get rid of the x's, divide both sides by 5. And 800 divided by 5 means my y-intercept is 160. Alright, so I'm ready to graph the intercepts from 80 on the x-axis, which will be right here, 80, to 160. Remember, I counted by 20s, so 160. On the y-axis, now connect those two. And it needs to be below that line also, because it's a less than. So my region, and I don't know if my eraser is going to allow me to get super, see if I can get rid of some of this. All right. So my region has to be above the purple line, below the blue, below the red, and still in the first quadrant. And so I am going to over highlight that, and I am looking at this really strangely shaped region right in here. And it has corners. Okay, 4 different corners. So we have a very oddly shaped quadrilateral. Alright, you guys, your drawing is probably, a lot of you are much better artists than I am. Alright, there we go. That is our solution region. Alright, so let's talk about the corner points. Okay, this corner point here, this was not 100. That was, the scale was 100, but it was 90 right in there. So I have one corner point of 90. I've got another corner point of 60, both on the y-axis. So my corner points are 0, 90 and 0, 160. But then I need to find this corner point here. All right, and that is the intersection of the blue and the red lines. Okay, I did blue and red for the second two equations. So let me clean this up a little bit. All right, so let's find the intersection of these two. We'll use the elimination method. I'm going to multiply by -5. So I'm going to take 4x, multiplying by -5. So negative 20x minus 5y. And I can use equals when I'm solving, remember. And I'm multiplying that by -5 also, so I'll have -900. And then the bottom equation was fine, so 10x plus 5y equals 800. And we will eliminate the y's, giving me -10x equals -100. So the x intersection point is 10. I can plug that back in to the top equation, the 4x equation. So 4x plus 10 equals 180. Oops. Plug it in for x, not for y. 4 times 10 plus y equals 180. So subtract 40 from both sides, so y is 140. All right, so this intersection point had x for 10, y for 140. Okay, so I'll add that to my list of corner points. And then finally, my fourth intersection point is the intersection point of blue with purple. And the blue and purple were formed by the top two equations. So I'm going to clean all this up again so I've got some space to work. And I'm going to solve the top two equations. That's a pretty easy one to solve. I can just multiply the bottom row or the top row by negative. Let's multiply the top row by negative. That'll give me negative x minus y equals negative 90. And then 4x plus y equals 180. So the y's cancel out, and I'm left with 3x equals 90. So x is 30. And if x is 30, y has to be 60. So my equation here would be 30, 60. And those are the corner points again. All right, you don't have very many where you got to do 3. Okay, I do recognize that 3 takes a while, so I didn't give you too many of those in your homework. I did give you a couple, but not too many. Okay, now, the last wrinkle we need to add to this is we need to give ourselves a new goal, which is called an objective function. Now, these problems start the exact same way. They're shaded. We find the corner points. They just have a different goal at the end, which is the objective. So let's just start with the constraints that we're given. Okay, looking at the constraints of being in the first quadrant again. Okay, we can do the intercept method. So x must be 4. And if I cross that out and get rid of the x, then y must be 2. And so this graph is going to connect us from 4 to 2. There's 2, there's 4. We connect, and we shade beneath because it is less than. I'm going to do my shading at the end. All right, and then the second equation, change colors, I'm going to go red. If I get rid of the y, then we know x must be 1. Okay, and if I get rid of the x, we know that y must be negative 1. Now this is interesting. We haven't seen this before. Okay, so I'm connecting 1 for x, but negative 1 for y. So I'm going to have to extend my y-axis a little bit. I'm going to connect 1 here and negative 1. So my graph would be coming like this. But I want to be below the purple because of less than. I want to be below the red also because of less than, but I have to stay in the first quadrant. And so I will be looking at a nice triangular region, okay, below purple, below red, but within the first quadrant there, not going below the x-axis. And so my corners. This corner is pretty clear, that is the corner 1, 0. This corner is pretty clear. That's the corner 4, 0. It's this corner that I need to solve for to find my intersection spot. And I'll do elimination to go back and solve that. Okay, so I'm going to multiply everything by 2. So multiply this by 2, multiply this one by 2, multiply that by 2, cancel out the y's, get 3x, and I get equal to 6, so x is 2. If x is 2, plug it back in, that'll be 2 plus 2y equals 4. And so 2y equals 2. So y must be equal to 1. And so that intersection point of 2, 1. And that looks pretty good for my graph. Okay, it looks like pretty logical. All right, so my corner points are 1, 0, 4, 0, and 2, 1. Okay, now what we need to add to this is the objective. The objective of this problem is to find the maximum value for f if f is 3x plus 2y. So that means I need to plug each of the corner points, a value for x and a value for y, into this equation for f and find the maximum. So f equals 3 times x. I'm going to do the first corner point, so 3 times 1 plus 2 times 0. F could also be equal to 3 times 4 plus 2 times 0, plugging in the second corner point. And the third option would be 3 times 2 plus 2 times 1. And one of those will yield the maximum. So this is 3 plus 0, which is 3. This is 12 plus 0, which is 12. And this is 6 plus 2, which is 8. So the maximum was this one. The maximum value of this problem is 12. It happens at the corner point 4, 0. And so it's like that's the winner, right? That is the objective, was to find the corner point that would give me the maximum value for f. I want to try one more of those with you because that's something new, and then I think you have seen enough to be successful in your homework. This is another one of those that we've got a 3 system, okay? So first quadrant, let's quick sketch our methods here. X is going to be, let's see how quickly we can get through that. X is going to be 3. Y would be 12. And I'll make that one in blue. And then for the next equation, X would be 6. And Y would be 6. And for the final equation, let's see, I'll do that in purple. X would be 15. And Y would be 30 divided by 8, which is going to not necessarily be the nicest answer. So we're looking at 3.75. Okay, sometimes it's good to think of these numbers at first so that you know how big your scale is that you got. So I've got to go to 15. So I'll scale this out, and I'll make sure that I've gone out to 15 for x. So I think I'll count by 2's again. 2, 4, 6, 8, 10, 12, 14, 16. So if I need to make sure I go out to 15, and then I'll count the other side the same. 2, 4, 6, 8, 10, 12, 14, 16. Okay, blue would be x is 3 right here. So I'll label that as 3. Connected to y is 12. 2, 4, 6, 8, 10, 12. Right here. Connect those two. Shade above. All right, keep that in mind. I'm going to do my shading last. Okay, I'll switch to red. X is 6, which is right here. Connected to y is 6. Connect those two. Also shaded above. And then the last one, x is 15, which is right here. Connected to 3.75. So the best I can do, connect those two. And I'm going to be shading above all of these. Okay, so let's see, I may have to stay in the first quadrant. So let's see what that looks like. If I stay in the first quadrant, and then I stay above the blue line, and then I stay above the red line, and then finally I stay above the purple line, and then within the first quadrant, this is my overall region. Okay, see that baby little section right there that did not get shaded because I've got to be above the red line altogether. All right, so here is my shaded region. Okay, the shaded region has how many corner values. Let's find them. Well, there's one here at 12. There's another one. Zoom in. Oh, that's unfortunate. I shaded that when I wasn't being careful. Okay. There's another corner point right here, and another one right here, and then one over on 15. Okay, so every time it like follows a different line or turns a corner, and then we've got these corner values here. So let's state the corner values that we know first off. The first one we know is 0, 12. That one's easy. And we know 15, 0. Those are the ones that are sitting on the x-axis and the y-axis. Okay, let's look for this one. And it's, notice because of my color coding, I can tell that is the intersection of blue with red. So blue and red are my top two equations here. Okay, that's blue with red. And so I'll use my elimination method to solve that. I'm going to multiply the bottom row by -2. So I'll have 8x plus 2y. I can use equals when I'm solving this. It's 24. And the bottom row by -2. That will eliminate the y's. I'll have 6x being equal to 12. So x is 2. And if x is 2, y must be 4. So this equation, or this intersection point, is 2, 4. So I'll add that to my list of corners. And then my last intersection point right here, again, if I use colors, is purple intersecting red. So let's get rid of this work. And if I want purple to intersect red, then I want the bottom two equations. I want these two. And I think I'm going to multiply the top row by -2 again. So -2x plus 2y, multiply by negative, minus 2y and -12. And then 2x plus 8y equals 30. So eliminate the x's. I'll get 6y equals 18. So y must be 3. And if y is 3, then x is 3. So this equation point right here is the intersection point 3, 3. All right, so now we have our 4 corner points. Now we go to the final step, which is the objective. This time, the objective is to find the minimum value for C, which is the smallest, if C follows the equation 2000x plus 4000y. So let's do C for each of our corner points. 2000 times the corner point of 0 plus 4000 times the corner point of 12. Or C could be 2000 times the corner point of 15 plus 4000 times the corner point of 0. Or C could be 2000 times the corner point of 2 plus 4000 times the corner point of 4. Or the final option would be 2000 times the corner point of 3 plus 4000 times the corner point of 3. All right, so this would be 0 plus 48,000 for an answer of 48,000. This one would be 30,000 plus 0, so answer is 30,000. The next one would be 8,000 plus 16,000 for a value of 24,000. And the last one would be 6,000 plus 12,000 for a value of 18,000. And in this case, we are going for the minimum. And so this one at 18,000 is the minimum. And so the minimum value is 18,000 located at the corner point of 3, 3. So the objective this time was not the max, but the min. The objective will be clearly stated in the problems. You don't have to come up with the objectives yourself tonight. You don't even have to come up with the systems yourself. Everything is given to you. You just have to do the graph and solve the math. We'll worry about coming up with our own systems and coming up with our own objective. That will be tomorrow's lesson. All right, so I hope you do okay with this. Good luck.